So this is Reigate Maths Year 2 Pure, and we're going to look at integrating trig functions by reversing differentiation. So we've got three formulae printed in the formula book here. So if we integrate cosec x times cos x, we get minus cosec x, and then you can see the other two here. Now, those are not in the formula book directly. If we look at the formula book, the section on integration is on page 7. Here we are, we've got integrals of sec squared x, tan x, cos x, cosec x, sec x, and so on. And this is where the formula for integration by parts is. But if we look on the previous page, page 6, we've got formulae for differentiating functions. What you've got to remember is that this is very useful for integration as well. So integration is the reverse of differentiation. So we can see here, if we had k sec of kx, tan of kx, so for example if k was 2, 2 sec of 2x, tan of 2x, the integral of that, we integrate that, we would get sec of 2x. So that's what we're going to use to integrate some functions. So if we go and look at the example in the course workbook, it says integrate cos x over sine squared x. So we're going to say the integral of cos x over sine squared x dx is the integral of, well, we're going to write this as 1 over sine x times cos x over sine x dx. We know that 1 over sine x is cosec x, so that's cosec x. We know that cos x over sine x is cot x, so cot x there, dx. And then we can see by going to our formula book, let's turn back to that again, we can see that we get, if we integrate cosec x cot x, well, if we integrate minus cosec x cos x, we get cosec x. So if we integrate cosec x cos x, we're going to get minus cosec x. So this is minus cosec x plus c. So often it's worth thinking before you integrate a product or a quotient of trig functions, can you rearrange it into a form where that differentiation table on page 6 of the formula book will give you some help. Before I finish, we'll just do one more example. So we're going to say if we want to integrate cosec squared of 2 theta d theta, well, we're going to go and look at our formula book again, and we're going to see that if we differentiate cot of kx, we get minus cosec squared, minus k cosec squared of kx. So we've got the cosec squared of kx, we just haven't got the minus k. So what we need to do is we need to do the opposite when we integrate in this case. So instead of multiplying by minus 2, we're going to divide by minus 2. So we get minus a half of cot of 2 theta plus c. And we can just go and check, if we look at our formula book, if we differentiate cot of 2 theta, we get minus 2 cosec squared of 2 theta. Well, the minus 2 times the half, they cancel each other out, and we would get cosec squared of 2 theta. It's often a very good idea, once you've integrated something, to check by differentiating it that you get back the function that you were trying to integrate. And that's it for this video on integrating trig functions.